and welcome to our webinar on tips and tricks mastering Modbus with AVEVA Edge software. I'm Erica O'Hara, and I'll be your host today. I'm joined by Mary Alice from AVEVA. Mary Alice is a pre-sales consultant, and she primarily focuses on AVEVA's HMI SCADA solutions, which includes AVEVA Edge. We're thrilled to be partnering for this session. AVEVA and ICP DAS USA has enjoyed a successful partnership for nearly 2 decades, and we're excited to share our combined expertise with you today. Modbus is a widely adopted protocol in industrial automation. Whether you're a seasoned engineer or just starting your Modbus journey, this webinar will provide you with valuable insights and best practices to enhance your Modbus implementation and unlock the full potential of your industrial automation systems. In today's webinar, we'll focus on Modbus, covering its structure, functions, and how to effectively utilize it in your projects. So our agenda for this webinar is to understand Modbus with AVEVA Edge software. We will explore the basics of Modbus communication, including its structure, and we'll then delve into ICP DAS USA range of Modbus remote I/O modules. Following this, Mary Alice from AVEVA will introduce the AVEVA Edge software and guide us on setting up Modbus communication effectively. She will also share valuable insights on building and simplifying SCADA systems, along with best practices for ensuring system security and a roadmap for AVEVA Edge. Finally, I will showcase ICP DAS USA's data acquisition equipment and demonstrate how it seamlessly integrates with AVEVA with our head engineer, Robert. To conclude, we'll open it up for Q&As to address any inquiries you may have about Modbus and AVEVA Edge. Before we begin, let me briefly introduce ICP DAS. Founded in 1993 in Hsinchu, Taiwan, ICP DAS has been a leading provider of industrial automation solutions for over 30 years. ICP DAS USA, established in 2001, serves the North and South American markets. We are committed to providing high-quality, reliable solutions and offer a range of benefits, including fast shipping, typically within 7 to 10 business days, free technical support, a 1-year warranty, and access to web-based and in-person training on PLC and SCADA programming. ICP DAS USA specializes in industrial control products and data acquisition systems. Our products are RoHS compliant and lead-free, and we maintain ISO 9001 certification to ensure adherence to the highest quality and safety standards. Our headquarters is located in Houston, Texas. What is Modbus? Modbus is a widely used industrial communication protocol for exchanging data between devices in a network. It enables client devices to read and write data from or to server devices connected on the same network. It operates via a client-server architecture to monitor and control digital and analog I/O. Modbus has been a standard protocol in automation for 45 years. It truly has stood the test of time. While Modbus initially relied on serial communication such as RS-485 in the form of Modbus RTU, it has expanded to include Modbus TCP, which leverages Ethernet for communication. This expansion has significantly broadened Modbus reach and applicability in modern industrial environments. A key factor contributing to Modbus' enduring popularity is that it's open source and royalty-free, making it accessible and cost-effective for a wide range of applications. Modbus was developed by Modicon in 1979 for use with their programmable logic controllers, PLCs. It has since evolved to become a widely adopted communication protocol used across various industrial automation systems, including HMI, sensors, and other platforms. Modbus RTU works using a client-server architecture. The client device sends requests for data and write commands to server devices connected through a COM port of the PLC, computer, HMI, or other Modbus client devices. The requests are sent to an individually addressed server device. Only the server that the request is sent to will execute the request while other servers stay in a listen state. A Modbus RTU network can have up to 247 server devices connected to a single COM port. Modbus RTU and Modbus TCP are two common implementations of Modbus protocol, each with its own characteristics. Modbus RTU utilizes serial communication, typically over RS-485 for data exchange. It is well suited for point-to-point or multi-drop configurations, where devices are connected in a linear fashion. On the other hand, Modbus TCP leverages Ethernet for communication, enabling broader network connectivity and higher data transfer speeds. Modbus TCP is often preferred for larger, more complex systems and those requiring greater flexibility and scalability. Here are two examples of Modbus RTU and TCP remote I/O modules. The M-7000 data acquisition remote I/O modules support Modbus RTU and DAQ protocols. They come in a wide variety of analog and digital configuration. The analog and digital I/O types they support include current, voltage, thermistor, thermocouple, frequency, relay, strain gauge, and more. The ET7000 Modbus TCP remote Ethernet I/O allow configuration, I/O monitoring, and control through a regular web browser. They can be easily integrated with SCADA software and other I/Os. Now that we understand the basic fundamentals of Modbus, let's explore how it plays a crucial role in data acquisition systems. Data acquisition is the process of measuring real-world physical conditions and converting the resulting data into a digital format for computer processing and analysis. This involves using sensors to measure physical properties like temperature, pressure, strain, or flow rate. These analog signals are then converted into digital signals using analog to digital converters. The digitized data can be then stored, analyzed, displayed, and used to control processes or make informed decisions. For example, in this diagram, you see sensors here and that collect information about the temperature, the pressure, or the flow rate. These sensors then convert this information into electrical signals that computers can understand. The ET7026 module receives these signals and convert them into digital format compatible with the control system. The SCADA system receives the digital data using Modbus TCP from the ET7026 module and process it according to its program logic. This might involve calculation, comparisons, and decision-making based on the sensor read. Data acquisition systems measure various physical conditions, including voltage, temperature, strain, pressure, and current by converting analog signals into digital data. Key components of a data acquisition system include analog to digital converters like ICP DAS USA's ET7017 and M-7017. Additionally, sensors such as thermocouples and ICP DAS CL201 series for CO, temperature, and humidity are crucial for data collection. Signal conditioning products like the SG3016 and the SG3011 from ICP DAS are used to prepare analog signals for accurate measurement and processing by the data acquisition. This diagram depicts a simplified representation of a data acquisition and control system within an industrial setting. It showcases how various components are interconnected to monitor and control a process. We'll delve into the key elements. So the sensors here, they are primary data sources measuring physical parameters like temperature, pressure, flow rate, etc. The I/O modules here, the ET7017, this module handles analog I/O, processing signals from sensors that measure continuous values like temperature. The ET2260 here, this module handles digital I/O, processing signals from sensors that measure on-off states or discrete values. Modbus TCP Ethernet. This indicates that the communication between the I/O modules and the PC occurs via the Modbus TCP protocol over an Ethernet network. In the PC here, you see this represents a computer running AVEVA Edge software, and that combines HMI functionality with data acquisition, processing, and control capabilities. AVEVA Edge provides a visual representation of the process, allowing operators to monitor data, control operations, and interact with the system in real time. And during this time, I will hand this off to Mary Alice, who will give us a better understanding of AVEVA Edge and its role in the industrial automation industry.
Thanks, Erica. Yeah, if you want to move on to the next slide here. So I kind of wanted to first start off with just a little bit of an overview of the history of AVEVA Edge, just in case anyone's not familiar. So back in 2013, Indusoft was acquired by a company called Invensys, which at the time, if you guys are familiar with Wonderware, the Wonderware solutions were part of the Invensys company. And so at that time, Invensys had Wonderware channel partners selling the Wonderware solutions. And so what they did is they created a version of Indusoft and called it InTouch Machine Edition for the channel to sell. So the exact same product, they just, gave it a different name for the Wonderware channel to sell. And so, it really didn't necessarily make sense for us to have two of the same products just with the different names. And so in 2021, Indusoft and Edge were both consolidated to just be called AVEVA Edge. And like I said, because they're the same solutions, you can actually open up Indusoft in the current version of AVEVA Edge, and it would just, need to recompile to run in the latest version, but, it all works the same. And so, from a high level, AVEVA Edge is really built to be an easy to use, powerful, and affordable HMI SCADA solution that can be deployed in a variety of applications. And so, with that in mind, there are kind of three benefits that I want to highlight today. So the first is around portability. So with Edge, we have the ability to run on many types of hardware and operating systems. Edge is, platform agnostic, so it can run on Windows as well as Linux operating systems. The second benefit here is around mobility. So we can run Edge on HTML5, which means we can have access to Edge on a smartphone, a tablet, a desktop, any HTML5 compliant browser. And this is great because this allows our customers to, have access to their information whenever and wherever they would need it. And then the third benefit that I want to highlight here is around interoperability. So what I mean by this is, we have the ability to support many drivers, and really have the flexibility to communicate with different brands of PLCs. And so I'll kind of dive into each of these benefits just in the next couple slides here. So if we take a look first around this idea of portability, in the development environment, which we call Edge Studio, this is where you're actually designing your application, building out your project, and then you actually have the ability to deploy those applications to various runtime editions, whether that be advanced a SCADA application on Windows runtime or embedded HMI or even, on a Linux device as well. And so the great thing about this is you can develop your application, develop that project once, and then deploy it wherever you would need it to be running. With the mobility piece of Edge, like I mentioned, we can run Edge on any HTML5 compliant browser to be able to view those project screens. And then we also have mobile access as well. So, you can view this on a smartphone, a tablet, wherever you would need to. And with this mobile access, you do actually have the ability to have read-write access. If you wanted to set that up, and you can actually restrict that based on user and group permissions as well. Also, just with mobile access, one quick thing is we do so no matter how you're viewing your Edge application, we do have auto screen scaling, and so this means that the screens can actually adjust based on screen size and orientation. And then finally, if we take a look here at this kind of interoperability piece of Edge, what you're able to see here is that we really have a wide range of communication options available within Edge beyond just PLC communication. So if we take a look here at this kind of diagram, I like to think about that middle icon representing the tags that are in AVEVA Edge. So if we look at the bottom left with, PLC communication, we have many different protocols to be able to integrate with the plant floor. We have, 4 or 5 different drivers for Modbus. There are 2 Modbus protocols, so we support both of them. If we take a look kind of at the upper left, we can be an OPC client for any one server. Kind of at the top middle, I talked about that mobility piece, so we can, interact through web and mobile. And then at the upper right, we can be a client or we can be a server for anyone's client. So, and then on the bottom right or on the lower right, we can also send data to a historian, whether that be the AVEVA historian or a SQL server or any SQL database or Pi or anything else. And at the bottom here, we have some toolkits available as well. And one thing that I kind of want to, make sure to point out here as part of this diagram is you can see here that all of the arrows are bidirectional. So this means that we can get data from anywhere and send the data anywhere. All right, so now I want to walk through how we can actually set up communication with Modbus and AVEVA Edge. So actually configuring communication with a device in AVEVA Edge is very simple. Within the Edge development environment, you can click to add a communication driver, and that will then open up this window here showing you all of the communication drivers that are available. And then you can just scroll down to click the one that you want to set up. And what you can see here is that, you can see the kind of 4 or 5 different Modbus drivers that are available, and you would just select that Modbus driver that you want to use. If you do need to do like any additional configuration, you can do that by going to the communication settings of that driver. And if you, as soon as you add your driver, the main driver sheet is automatically created. So we actually have 2 different driver sheets. We have the main driver sheet and a standard driver sheet. So the main driver sheet, it scans at a rate of 600 milliseconds by default. The standard driver sheet, it actually has a lot more power and flexibility. So if you want it to go as fast as it can, you can put a 1 in the read when idle field, and it will go, it will read as fast as it possibly can. With the standard driver sheet, you do have to pay a little bit more attention when you're, kind of setting it up. You can only have 1 data type in the standard driver sheet. And, just a couple other things. There's just a little bit more complexity with configuring it. So originally, AVEVA Edge had only had the standard driver sheets, but actually the current product manager requested for the main driver sheet to be added. And the reason for that is because before he was the product manager, he was actually a customer. And as a customer, he didn't really care about everything that you can do with the standard driver sheet. He just wanted to be able to put everything in one driver sheet, be able to do a mixture of data types and have it, manage it all for him. And that's when the main driver sheet was added. So you can add all your data types, and it will kind of optimize it and work it out for you. So just one other thing, I guess, about the main driver sheet is what you are able to see here is that we have kind of four status fields: read complete, write complete, read status, and write status. And these actually help with troubleshooting. So a lot of our customers, don't necessarily use these status fields, but they really should be using them, because if you need support, the first question that support is going to ask you is, what's the error code? And that comes from these status fields. So in order to configure the driver sheet with Modbus, you first need to determine the register type, and then you would associate each tag with their device addresses. So, just for example, I have 3 tags here. If we take a look here at my temperature tag, it's the input register. So that is going to be indicate that it's the 3x. And then it's in the address associated with 1. So in my IO address for temperature, I would type 3x:1. The last thing I want to talk about here is tag integration. So, we saw on the previous slide how we can associate tags with addresses for the communication driver. And so what tag integration does is it allows us to directly integrate tags from a third-party control application or directly from the PLC into the Edge project. So the registers added using tag integration will be live as soon as you run your project, and they can be used anywhere in your project. So instead of having to manually configure the driver worksheet and then associating each tag with each IO address, you can actually just configure, where the PLC is, or, where the file is that you're, using as your reference. And then the object finder will connect to that PLC or connect to that file and show you all of the available tags. And then you can kind of pick and choose which tags you want to communicate with. And so then in the background during runtime, tag integration is kind of creating a virtual main driver sheet. All right, so now I wanted to spend a few minutes going through some tips and tricks with AVEVA Edge. So in AVEVA Edge, we have the ability to create classes, and classes allow you to have a data structure for your equipment. So for example, let's say I have a plant where I have, multiple tanks. Instead of having to define each individual tag for each individual tank, I can create a tank class with the tags associated with my tank. And then in my project tags, I can use the tanks that represent the actual tanks within my plant. So I can do that by either creating, within my project tags, I can create tank 1, tank 2, tank 3, or I can do an array and say, I have 3, tanks in my array. And so then what this means is when you would go to reference your tags in your project, the way you would reference that is tag name.class member. So if you kind of just click through these next couple pictures here, in my example here, I would have tank dot level, or if you had an array, it'd be tank, in the brackets, maybe 2, for example, if it's tank 2 dot level. If you click maybe 2 more times. So really these classes just kind of help with, allowing for greater efficiency when building out your project. So the next thing that we can do with an Edge is indirect tag referencing. And so what this allows us to do is actually we can point to another tag in our project, which gives you some flexibility. So what I have here are a couple of examples of how kind of indirect tag referencing works. And for the sake of time, I'm not going to go through all of the details here, but essentially what you can do is create a string tag that references another tag in your project. So for example, maybe you have a tag called temp. You could create a string tag that you call X, for example, and every time you say @X in your project, the value of that temperature tag would be displayed there. And so this could be really good if, let's say, you have one tank graphic on your screen with, maybe some different, values for that tank. But let's say in the real world, you have 3 tanks. you could just use that one graphic and then be able to reuse it for all three of your tanks by using indirect referencing to be able to dynamically change the tags during runtime. So the next thing to talk about here are custom properties. So these are actually placeholders or aliases that can be configured to screen scripts or screen animations and object properties. And so what this does is it allows you to configure like generic symbols or screens and then be able to assign values or tags or expressions to those symbol or screen properties dynamically during runtime. And so what you can do is actually kind of reuse like templates of these symbols or screens, really just to help kind of with efficiency of building out your project and even, consistency and quality because there's, going to be standardization there. So for example, let's say you have 10 valves. Instead of having to build that graphic for the valve 10 times with all of the colors, the commands, the labels, the alarms, everything, you can actually build that once and we can call that the master symbol. And then you can create instances of that graphic for each individual valve. And then since you have, different tags from the PLCs for each of the valves, you can then use the custom properties to assign different values to each instance. But you're reusing the same template graphic, that same master symbol. And we can do that for screens as well. So, maybe you want to have a pop-up screen to show details for each of those valves. You can build one master screen, and then when you open the screen, it will dynamically populate with the details for the particular valve that you're wanting to show details for. So I have a couple of videos here in the next couple slides that will kind of show you how this works. Just briefly before we get there, this table here kind of shows the syntax for custom properties. So, we can do these custom properties for values, text, tags, and expressions. So in this first video here, I'm showing how we can use custom properties with symbols. So what I'm doing is I'm creating an ellipse and creating a tag called motor A command. And then I'm going to add a button to the same tag, that motor A command. And what this is going to do is going to toggle the tag between off and on, which you'll be able to see here when I go into runtime. So I can turn this, motor off and on. So then what I can do is I'm going to update the symbol to be a custom property using the syntax pound motor motor A command. And then I'm going to do the same thing with the button. And then I'm going to create a linked symbol and save it. And so now when I go to the properties of my symbol, I can see the custom property for that symbol, which was the motor A command. Now I'm going to duplicate that symbol and I'm going to create a new motor B command as a new tag. And so then when I run my project, I can see I have two separate symbols for two separate motors, and I can turn each one of them off and on. And I just had to do that configuration really once, and then just update the custom properties for each of the other symbols. So in this video, what I've done is I've created a screen to be a pop-up that will show more details about my motor. So I'm going to have a button, and for this button, I'm going to create a script that will open up the pop-up screen. So in this script, I'm going to open up the screen called motor. I can enter the coordinates, the size. I can say if I want it to be resizable, can enter in kind of the string properties here. And then what I can do is have a list of pneumatics for the screen, and I'm going to define the custom property and the value for the custom property here. So for example, I can open up, this pop-up for motor A and motor B. And then what I can also do is, maybe I want to include the motor name as part of that pop-up. I can add that custom property to my screen, do the same thing for, my motor B here, add that name. And then within that pop-up screen, I can, include that motor name to be shown, using my custom properties here. So we'll do that. Pound motor name to show it. And then what we'll be able to see now is during runtime, as I open up each pop-up, it's going to update to show me, am I viewing motor A pop-up or motor B pop-up? All right, and then really just the last thing here that I kind of wanted to point out is that AVEVA Edge projects are not compiled, so the development environment works on configuration files. And what this means is I can actually create Edge projects on the fly. So if we take a look at this pyramid here, so and kind of start at the bottom. So for a new user, a new developer, who's kind of first starting out, they would need to first build out their Edge project and do all of the customization and do all of the configuration for building that out. If we go up to the next level here, maybe there's an Edge developer who has some experience. They can start to build some reusable content, symbols, screens, windows, and dynamically assign IP addresses and things like that. So they already kind of have a little bit of a basis of things that they can reuse. And then at the top here, we can get to the point where developers can actually programmatically create content and assets on the fly and then deploy those on site without having to do all of the customization and programming. So just as an example of this, there's actually a lot of prisons who use AVEVA Edge. And so what these developers will do, if they're going to go install AVEVA Edge in a new prison, they already have the project built out with the facility diagram. They can actually import that facility layout into Edge. Then they can drag and drop the icons like the cell doors, where the cameras are, where the TVs are. And then all they have to do is deploy it. So rather than have to configure the Edge project, they're just having to really deploy it. And so that goes, instead of taking weeks or months to build it out and deploy, it can go down to hours. All right, so next I'm going to talk a little bit about cybersecurity and authentication in Edge. So all of our AVEVA projects our products are designed to meet the secure development standard, which you can see here in this image. Also on our website, which I've included as the second bullet point here, if you go to this link, it will take you to our cybersecurity updates. And so this is how we keep our customers updated with any cybersecurity vulnerabilities. Also within the AVEVA Edge help documentation, we have a section that provides kind of an overall or an overview of how to securely deploy your Edge project as an industrial control system application. And so we really highly recommend following the guidelines that are outlined within this document. I've included a link here as well to that PDF. It's also in the Edge help documentation as well, but there's really a lot of information here, but it kind of goes through an overview of ICS, the typical system topologies. It identifies typical threats and vulnerabilities to these systems, and then also provides some recommended security measures to mitigate those risks. So also within Edge, thinking about kind of the authentication side of things now, we can set up security settings. So the security system for Edge has several security modes. You can configure your groups and users locally within your own project settings, or you can get, predefined groups and users from another project or domain server. And so there are 4 security modes, which are local, that's the standard, distributed server, distributed client, and local plus domain. Then within the security settings, we can actually create groups. And what you can see here is there are 2 sections. We have runtime access and engineering access. And within each of these, we can assign security levels and then also give or restrict access to certain things as well. And groups can have different access between the 2 sections. So maybe you have a group called operators where they don't maybe need as much access to the engineering side of things, but they need access to most things in runtime. They may have a lower security level within engineering access than they do for runtime. And then when you create your users, you can assign them to the group or the groups that they're part of. So I talked a little bit about setting the security level for a group. And so just a brief example of that is I have this guest group here, and you can see that I've given them a security level of 0 to 10 for runtime access and engineering access. And so I can actually set security for objects in Edge. So this picture is showing actually the script for the button that we were looking at earlier for that motor A pop-up, but I can actually set the security of this button. If I set it to anything higher than 10, so like in this case, I've set it to 15, then any user in the guest group if they try to click this button, it will not do anything. And then I can also set security for screens as well. So I set, security for 15 for this screen. So if users in the group, guest group, try to open up screen 2, they would not be able to. So just kind of the last thing that I was going to go through is I wanted to briefly go through some of the updates that came out with our most recent Edge release, which was 2023 R2, and that was released last July 2024. So just to kind of, briefly talk about this, we made some updates around cybersecurity. One thing that we really do, that the product management team does a really good job of is getting feedback from customers. And so a lot of the customer issues and feedback that were received were addressed with this release. There's been some updates around performance with the grid object and tree views and mobile access. Some updates to the industrial graphic library. We don't really talk about that. Those are in case anyone is not familiar, those are the graphics that we use as part of our AVEVA HMI SCADA solutions. We have the ability now to do import SVG graphics into the industrial graphic editor. But really the biggest update with this release is the ability to now run Python scripts within AVEVA Edge. So I'm going to talk about that just in the next couple of slides here. So if you'll go, yeah. So with the Python editor, we're really doing everything in a common way. So this editor was chosen to be common and consumed across all of our AVEVA HMI SCADA products. The editor supports external Python modules. So this means that you can integrate and use additional Python libraries and packages that are not built into the standard Python distribution. And as part of this, so we have background scripts, and these can kind of help with carrying out continuous or periodic tasks without interrupting the main application. The startup procedures, these will execute automatically when the application starts. And then we also have global procedures that can be accessed and used throughout the entire application. Edge uses CPython, which is more compatible with third-party libraries than some other variations of Python. And then also, the Edge Python has a fully functioning IntelliSense, so it will start to kind of type ahead and autofill as you're, building out that script, which is really nice. And so just to dive, a little bit further into this, so previously Edge was developed it just had VB script. And so unlike VB script, Python was built to run as a non-graphical script performing tasks in the background. And then the plan will be to eventually add Python into industrial graphics. It was built to be developed in a way that other AVEVA products can adopt it easily. So it was actually developed using a namespace not specific to Edge. And so what we're working on is being able to, eventually be able to copy a Python script in Edge and then paste it in another product. And then just a couple other updates to kind of highlight here. So, Edge has had this history lifetime feature in the Windows offer for many years, and it's now been added to the IoT view, which is the Linux offer. So this is really just a way to help with kind of housekeeping trend log files. So if it's set to 0, everything will be kept. If it's set to 7, for example, then it will get rid of 8-day-old data at midnight on the 7th day. So it's only going to keep 7 days worth of data. And the first one is the first one out. We talked about the main driver sheet and the standard driver sheet earlier. So for Linux, we've added support for standard driver sheets. And again, these just kind of give you a little bit more flexibility and control than what the main driver sheet offers. And then we talked about tag integration as well. And so now we've added this in the Linux offer as well. And then, just the final thing here is I wanted to kind of show you some of the plans for the next release of Edge 2026, which is planned to come out later this year. A lot of this, or all of this, is subject to change. But just to briefly overview, we still have plans to continue to make updates to cybersecurity, um, as well as the industrial graphics library, some updates around mobile access, as well as some updates around the drivers as well. So I think that's it for me, Erica. I'll hand it back over to you.
Thank you, Mary Alice. I'm going to show here one last slide on my part, and then I'll give it to Robert, who's our head engineer here, and he'll show you live how to integrate one of our AT or IO module with AVEVA Edge. So I wanted to share here with you all an example of how ICP DAS USA's data acquisition technology integrates with AVEVA Edge. So you see here, this image showcases a data acquisition application for a wastewater treatment plant powered by AVEVA Edge. The central element is the AVEVA Edge HMI screen here, you see this? Displaying real-time data and process visualization. The screen features a representation of two sedimentation tanks along with like flow rate status. This visual representation provides engineers with a clear overview of the plant's current state and enables them to monitor the process effectively. Below the HMI screen, the image highlights key components of the data acquisition system. The photograph here depicts a wastewater treatment plant with a flow meter, emphasizing the importance of accurate flow measurement. Additionally, the ET7017 module is featured. It's responsible for acquiring data from the flow meter sensors and transmitting it to the AVEVA Edge system via Modbus TCP. This integration of hardware and software allows for comprehensive data collection and analysis, enabling operators to make informed decisions and optimize the wastewater treatment process. At this time, I want to actually have our engineer Robert show us live how to connect this ET7017 module to the AVEVA Edge system, showcasing the ease of integration and configuration. Go ahead, Robert.
Okay, thank you, Erica. Let's see, let me set up my sharing so I can show my video of this live. Here you go, I'll play it and we'll answer questions shortly after this. Today, for our hands-on demonstration portion of the webinar, I will show you how to connect a Modbus TCP server to AVEVA Edge. Our connection will be similar to this. We have a PC with AVEVA Edge installed. Connected to our PC is our ET7026 Modbus TCP data acquisition module. The ET7026 acts as a Modbus TCP server to the AVEVA Edge software, which is the client. The ET7026 has 4 I/O types, AI, AO, DI, and DO. Connecting all 4 are very similar. I will show you this in the next few steps. Here is a list of the information that I will use to create this connection. The ET7026 is a Modbus TCP server or slave. Its IP address is 192.168.0.230. This has been pre-configured. It's on the same network as the PC with AVEVA Edge. It uses Modbus port 502, and its slave or module ID is 1. We will set up the following registers. The address shown here are base 1, which is what AVEVA Edge uses. We will set up 2 DI registers, 10,001, 10,002, or in PLC format 1X001 and 1X002. We will set up 2 DO registers, coil addresses 1 and 2. We will set up 1 AI register, 30,001, and 1 analog output register, 40,001. Within AVEVA Edge, we will use the MOTCP or Modbus TCP driver. We will set up a main driver sheet similar to the one shown on the right side. The tag names you create are sort of nicknames for what each tag represents. In this example, pump 1 or pump 101 and pump 102, a valve or surge valve and control valve. But you can name it anything you want. You just need to nickname it so you can identify what IO point is connected to that. The station ID for Modbus TCP is defined as shown. The IP address, a colon, port 502, or port number. By default, it's usually 502, then another colon, then module ID, which we defined on the previous slide. This is the slave ID for the Modbus TCP connection. Most of the time it's 1, but if you have some special circumstances, you can change it as well. Let's go to AVEVA Edge now. Let's see, where is it? Here we go. There we go. Okay, so I pre-created this layout just for what I want to show during this presentation. So I have 2 DI registers represented by pilot lights, 2 DO registers represented by push buttons, an analog input and analog output. I'll also display the values here and here if things go right. For this, the first thing you want to do is go to your COM tab down here. Let's see, click on drivers and right click and add driver. Okay, then let's see, the list of drivers shows here. These are all the pre-installed drivers with AVEVA Edge that come with it. For this example, we're going to use the MOTCP or Modbus TCP driver shown here, but there's many others you can use as well in your project. It will show up down here. So I have selected it and I click here. Next thing over here, the driver shows up here, MOTCP. If you do need help with the syntax or anything, the help document is wonderful. You just click on MOTCP and right click and select the help document. It appeared over here. Let me drag it over. And we'll maximize it. This is the most useful page that I find. It's got some examples for each specific driver type. For instance, if you're using floating point, you want to do swapping bytes, you can do that here with the syntax shown here. For this, I'm just going to use the basic format, but if you want to use floating point numbers or anything, or find out how to do scaling, you could do that from this document. It's probably, what is it, 38 pages long, so it's a very detailed document, but let's close that or minimize that. So the first thing you want to do is go to the comms tab, and we're going to modify our Modbus TCP driver. So you just double click on it. The main driver sheet appears here. So I click on or double click on that. And let's see, I did pre-fill it out. So I created my tag names here. 2 DI channels, 2 DO channels, 1 AI and 1 AO. The station ID is shown here, 192.168.0.230, colon 502 and colon 1. For the IO addresses, I did fill it out as well. They're shown here. And let's see, I did select the read-write properties here. Okay, so now I can right-click here. And let's close it. And let's make sure my tags are over here. I may have deleted them. I did, so I need to recreate them so that they'll match. DI0, DI1, DO0, DO1, AI0, and AI or AO0. For these, you can select the types here, but for this example, I'm just, well, I guess I will change it to Boolean since these are digital IO, but you can just leave it as integer as well, because realistically, it's only going to show a value of 0 or 1. For the analog channels, I'll just leave those integers. And now that I have this saved here, I can go back here and do File, Save All. And I also want to go to my Graphics tab now. And let's associate these with the individual graphics. So for this one, I want to do digital input 0. There. This one, digital input 1. Okay. This one, DO0. This one, DO1. This one, analog input 0. And I did modify the maximum value to be 1000. You do want to have that correspond with the tag value. In my case, it would probably go up to 10,000 because I am using analog input for 0 to 10 volt, and I believe it has 3 decimal points. So I want to add an extra 0, so it'd be 10,000. And let's see, we can just modify this so that we can see the value here. I'm going to modify this one so that we see the analog output 0. And finally this one, so we can do AO0. Actually, you know what? You can also use the 3 dots. Let me erase this. And let me just show you with the 3 dots, you can actually view your existing tags as well. So you can select from the list as well. And let's see, let's run this project and make sure that it works. And I do have my Modbus master tool, which is one of our utilities here, also running. And with this, I can modify and control a few of the values. Let me slide this over here. So for the coil registers, 0 and 1, I have one of them on and the other one off. So let's just turn them both on. And for the analog output register, I had a value 156. Let's make it 245. And click OK. And we should see the corresponding values change over here. So on and 245. Let's just manipulate those one more time to make sure that it works. Let's just turn both of these off and off. And let's modify this to, let's do 989 and click OK. So let's minimize this. And 989 and off and off. So we are working. Let's see, with AVEVA Edge, let me also show you one more thing. Within the software, there's these images, plus there's a whole bunch more that you can use in your project design. So under the project menu for the draw menu, actually, the symbol library, this is where I heavily use a lot of the images. Going a little slow on my computer, but okay, the ones I use a lot are the pilot lights, the buttons, which are predefined buttons that AVEVA Edge has for some of the more popular functions. Specifically, I almost always use the exit button here, and there's log in and log out for if you want to do security or login information. There's a few other tabs. The other section I use is the sliders quite a bit. And the push button section. These are just predefined images, but you can create your own. And if you need some specific to an industry, I have asked AVEVA before, and they do have some other pre-existing objects for specific industries. And finally, one last thing I want to show you is, let's see, the PC demo that comes with AVEVA Edge. It just shows off all the graphics and some of the animation features you can use. Let me run this. And I like to show this so you can get an idea of what you can use in your project. And just under features and animation here. You can do bar graphs, you can do color change, you can do rotation. The size is kind of neat because you can visually show the status of your I/O. The trend, you can graphically show the value of some analog tags, and there's some industry examples as well. But let's see, I'll pass this presentation back to Erica, and she'll finish off, and we'll be happy to answer any questions at the very end. Thank you.
Thank you, Robert. Thank you all for joining us today. We hope this webinar had provided you with valuable insights into Modbus communication and its integration with AVEVA Edge. We encourage you all to explore the resources available on our site. You can see here our website, icp-das-usa.com, or reach out to our team if you have any questions. You see on our site here our email address. Thank you for your time and participation. If you have any further questions, please don't hesitate to contact us. You can find our contact information on the screen. Thank you and have such a productive day.